On to the exercises, which we will use the bikes data frame. Find the number of rides between trip durations 0 to 100, 101 to 1000, and 1001 and above. So we're going to cut the trip duration column over here. And this is what we need to pass in. We're given the exact bins. And we actually need to find the maximum value of trip duration to figure out how high the last bin needs to go. So 86,000, so we'll just put 100,000 to cover it. So there we go, and value counts. All right, so here it is. This is in seconds, trip duration. So this is actually a very short ride. So there are 242 rides that are within here. 40,000 that are between 100 and 1,000 seconds, and then 10,000 that are more than 1,000 seconds. All right, number 2, cut the trip duration into 5 bins where the width of each bin is the same size. Right, so that means we're going to use pd.cut, count the occurrence of each bin. That means we will pass it to value counts, and then sort by the index. Okay. Does it make sense to use this type of binning? All right, so the results here are pretty strange. It says almost all of the data, well over 99%, is concentrated in the very first bin. That's just because the very last ride is so long that it really spreads out the data, and that there's just very few rides over here. So this type of bin doesn't really make sense to use. It's interesting. It tells us, the vast majority of the data is in this first bin. So we have to investigate why there's, why are there these outliers out here? But it's hard to, doesn't really give us nice groups to really work with. This is what exercise 3 does. It says to cut the trip duration column into 5 bins where the number of observations each bin is approximately the same. Okay, so that clues you in. It should be Q cut. Count the occurrence of each bin, sort through series by the index. All right, so these now more accurately show what is going on. And you can see the very last bin has a huge number of possible trip durations from 1,000 all the way to 86,000. And this gives us a much clearer idea of where the trips are taking place, how long the trips are. So you can see here the counts are roughly all the same, about 10,000. All right, number 4, cut trip duration and temperature into 5 equal size bins and count the occurrence using pd.crosstab. Really, I wanted you to use qcut over here, so let's just do that. We'll call this TD, and then we'll do the same thing for temperature. And we'll call TD bins temp bins. And then these are a series, so we can just pass them into crosstab and say index TD bins, columns, temp bins. All right, so, and this will sort it. Here's temperature, it'll be sorted, and trip duration is sorted. So this first bin is saying from the lowest temperature, unfortunately uses negative 99.99 for missing values. But anyway, this is for cold temperatures of short trip durations. Has this much. So we can see what happens as the temperature increases over here. Are there any patterns over here? And it actually tends to be that, let's see, as the, at least, okay, so the shortest trip durations, as temperature increases, we actually get less number. This is just, remember that crosstab is the count, right? So this is a smaller number. And is this true for all of them? So it turns out, so the longest trip durations appear when the weather is warmer. So when it's colder, you have a shorter trip, so maybe that makes sense. In that, all right, so if it's cold weather, people are looking to ride less. If it's warmer weather, people are actually riding more. So interesting pattern. Obviously, there's more to this. that can be explained, but we can sort of come up with a story based on the data that we have in front of us. All right, number 5, create a pivot table containing the average trip duration by gender and temperature cut into 10 equal sized bins. All right, let's do temperature. And again, we'll just say 10 bins. And then we're going to do a pivot table. So we'll do bikes.pivot table. We'll say index equals, we can actually put the bins over here. Columns equals gender. And then now we're going to aggregate trip duration. And then the ag func will be mean. So now we can look at this. So we can say, what is the average trip duration by gender? And so there's actually, looks like a significant difference. Number 1 is that females tend to take longer rides for every single temperature range. Looks like that's true. So, and if I round this, let's just round this to the nearest 10, make it a little bit easier to see what's going on. Right, we can see that 800 is greater than 710. So yeah, every single temperature range, females are taking trip durations 10 to 20% longer. So a little interesting that there's a differences between the genders. All right, number 6, the temperature column has a single obviously wrong value. Replace this value with the NumPy nan object and then cut the resulting series into 5 bins, labeling them cold, cool, mild, warm, and hot. Choose the boundaries of the bins that make sense for these labels. All right. So the series, the temperature series, so if we look at this, has just a clearly wrong value. If you do value counts, which is kind of weird to do on a temperature column, but then sort the index, you can see that this one is clearly wrong over here. So what we want to do is just replace this value with a NumPy nan object and then cut the resulting series into 5 bins. So let's go ahead and do this replacement. So we'll do -99. We need to import NumPy like this. So let's actually turn it into a float. And then we can cut the resulting series into 5 bins. So that you get to choose the bins here. So we'll say pd.cut. And then the bins will just say, we saw the negative, the last one was -8. But we can just, so we can just put -8. And actually it's probably good to move some code around over here. Let's just call this S. Now we'll find the min and the max. So -8 and -96 or 96.1. So pd.cut S, and we'll say, all right, -8 to I don't know, maybe 32. That'll be cold. Cool will be 32 to maybe 50, mild maybe 50 to 60, maybe 65, warm 65 to 80, and then everything above that is hot. I know the hot is a -96 or 96.1, but we can keep it like this. We can actually, just in case there's maybe new data that comes in. All right, now we need to give the labels, and we can just copy and paste these labels actually, and they'll work out just fine. All right, so there are the labels, and then we can just count the occurrence of each, including the missing values. That value counts, and there's a drop NA, which we will set to false so we can know how many. So there's only one missing value over here. Okay, so pretty cool. And we can actually sort by the index. So it is an ordered categorical. So we go from cold to hot. So maybe an easier or nicer way to look at the data over there. Okay, that is it for the exercises.